Okay, I guess we're on. Good morning, everyone. So for today, we'll continue our discussion about the Lagrange, about algebraic interpolating polynomial. Just a quick recap of what we did last time. Last time we talked about a common problem in mathematics in general. Whenever we want to apply those tools that we learned from our calculus courses into real life problems. But again, in real life, usually what we get are discrete set of data, discrete and finite set of data. So ibig sabihin, hindi natin magagamit yung mga tools sa Math 36, which taught us how to use derivatives, integrals, and other things in order to manipulate or analyze a certain function, like finding its minimum, its maximum, etc. But in real life, discrete yung set ng mga data na nakukuha natin, so hindi kagad applicable yung mga tools na natutunan natin sa Math 36, 37, and 38. So that brought about polynomial approximation or function approximation, wherein we want to fit a certain function into the set of data that we have. And further maka-classify natin yung approximation into several classifications. But our main focus would be on interpolation. In interpolation, we have the data set. We want the function that will come out of our approximation to pass through exactly those points. So yun yung interpolatory requirement. What distinguishes interpolating polynomial from other form of approximation? Kailangan dadaan siya dun sa mga points xi, f of xi na given dun sa problem. Then last time we have a very important result, which is the Unisolvance Theorem, which guarantees not only the existence of an interpolating polynomial of degree no greater than n, but also promises that this polynomial will be unique. So pag binigyan ka ng n plus 1 data points, sigurado tayong laging mayroon tayong makukuhang polynomial of degree no greater than n na dadaan dun sa lahat ng mga data points na yon. And that's the beauty of polynomial interpolation. And not just that, because polynomials are usually easy to manipulate. Kayang-kayang gawin or computein ng machines ang function values ng isang polynomial because in polynomial evaluation, all we use are the basic arithmetic operations, namely addition, multiplication, subtraction, division, and probably exponentiation, which is just repetitive multiplication. Tapos, ang derivatives at integrals ng polynomials ay polynomials pa rin. So, marami tayong pwedeng gawin with polynomial approximants to a certain given set of data. Okay. Now, we proved the unisolvance last time, and the proof did not only have a very theoretical implication, but also a practical one. Because in the proof for the existence, we actually saw one way how to create such an interpolating polynomial. And that is what we call the Lagrange form of the algebraic interpolating polynomial. And that's what you see in the current slide or in the current page. We have definition 3 here, which is the Lagrange, which defines the Lagrange form. So again, given tayo ng n plus 1 data points. So we have x values and their corresponding function values, right? And then the algebraic interpolating polynomial in Lagrange form relative to these points is given by this polynomial p. Note that each of the terms in the summation has this constant, which is the function value at the given node, multiplied by this guy, L sub k. And L sub k, as we mentioned last time, is what we call the Lagrange basis polynomial. And it is so constructed by taking the product of linear factors of this form, x minus xi over xk minus xi, provided that I is not equal to k. Okay. So yung subscript, yung kth Lagrange basis polynomial, denoted by or marked by this subscript k, yung subscript k na yon, siya yung nagdidikta kung ano yung minuend dun sa denominator ng bawat factor. So bawat factor dun sa kth Lagrange basis polynomial will have xk in the minuend. And that will remind you not to include xk in one of the factors, or do not use the linear factor with an xk as subtrahend in the numerator kasi sa denominator magkakaroon ka ng xk minus xk pag pumayag ka na yung I ay equal kay k. So, simula siguro nakakalito yung Lagrange basis polynomial, how to define it. But basically, for instance, if you want to have the first Lagrange basis polynomial, remember, product lang siya. So, product siya ng mga merong x1 minus something sa denominator. Okay. Times hanggang dumating ka dun sa pang n plus 1 na factor, or actually n factor. So, tapos alam natin na yung minuend in the numerator and the denominator will iterate from 1 to n plus 1. Kasi parehas lang itong mga subtrahend na yan. Pero again, we cannot start at x1 being a subtrahend kasi magkakaroon ka ng x1 minus x1 dun sa first factor. So meaning we should begin with x2 and avoid having an x1 as a subtrahend. Okay? Tapos yung minuend sa numerator, variable x lamang. So x minus x2 kasi dapat laging parehas yung mga subtrahend. And then here we'll have x1 minus x3. X minus x3 pala. Then next, x minus x4 all over x1 minus x4. Hanggang dumating tayo sa dulo, which is x minus x sub n plus 1 over x sub n plus 1. Okay. And then, if you will count how many factors we have here, actually, nagsimula tayo sa 2 hanggang kay n plus 1. So we have n factors, and that's why each of the Lagrange basis polynomials is of degree n. Kasi laging may isang nawawalang factor. So if you want to do x sub 2 or L sub 2, the second Lagrange polynomial, ibig sabihin, bawal ako ritong lahat ng minuend sa denominator magiging x2. Okay. Kasi nagmamatch yung minuend sa denominator with the subscript of the Lagrange polynomial. Tapos, syempre, bawal ka na magka-x2 dito. Kasi dapat magsimula, kasi magkakaroon ka ng x2 minus x2 sa denominator. So, we should start with 1. Skip x2 in the creation of the factors. Pero okay pa rin na merong kang x3 dito, x4 dito, hanggang x sub n plus 1. But essentially, there's still n factors here kasi ang natanggal lang naman ay si x2. We began with I equals 1, tapos natapos tayo sa n plus 1. So basically, that's how you define the Lagrange basis polynomial. And to get the polynomial p, multiply mo lang yung kth Lagrange polynomial by the kth function value. Okay? So I hope this is making more sense now because I remember last time, isa sa mga comments is parang mahirap intindihin or mahirap i-imagine ano yung itsura ng Lagrange basis polynomial in the proof. Maybe it would be even better if we look at a particular example. Oh, but before going there, let's have the first remark muna. So, the Lagrange interpolating or the Lagrange form is not the only form for the interpolating polynomial. There are other ways how to create the interpolating polynomial. For instance, there is what we call the Newton's form, which makes use of divided differences. Pero since sabi nga ng Unisolvance Theorem, kung meron kang mga set of data points, laging unique yung makukuha mong interpolating polynomial. So it doesn't matter if we use the Lagrange form or the Newton form, we will eventually end up with the same interpolating polynomial. Basta pare-parehas yung data points natin ginagamit. Okay? So that's why I forgo the discussion of the Newton's form. If you're interested in looking at the Newton's form, you can refer to last year's Math 174 modules. Tinanggal ko na siya para umunti yung kailangan nating i-discuss. So this is on pages 3 to 6 and of module 3 last year and the entirety of module 4 last year. So I have here the links if you want to visit this. And if you're thinking right now of what your project would be, you can take a look at the Newton's form. Okay? Kasi pwede nyo gamitin kahit anong method na hindi nagamit sa klase. Or actually, hindi pa pala tayo nakapag-decide, no? Pwede kayong gumamit ng mga methods na hindi nagamit sa klase. pero hindi naman kayo restricted sa mga methods na hindi natin na-discuss. More on the guidelines for the project later. Pina-finalize pa namin. Okay? Now, again, to build up our understanding of the creation of the interpolating polynomial, let's consider some easy examples. Okay? Kasi lagi kong, I find it easier to write a program or write a code for a method or a certain application if I know how it works. And one way to learn how it works is to do it by hand, at least for specific or small examples. So look at example 1. The instruction is to find the interpolating polynomial for this data set, 1, 1, 2, 4, 3, 9. Okay. Now, if you just observe the data, mukhang ang function lang na ito ay x squared. Kasi 1 squared is 1, 2 squared is 4, 3 squared is 9. And it would be a perfect fit for an interpolating polynomial kasi number 1, y equals x squared will pass through all of these 3 points, thus satisfying the interpolatory requirement. And also, we have 3 data points. So the algebraic interpolating polynomial will be of degree 2 or less. And x squared will definitely fall into the category. So dahil by inspection, we know that y equals x squared is the algebraic interpolating polynomial for these data points. Kasi nag-pass through siya dun sa 3 data points. Tapos yung degree niya ay 1 less than the number of points in the data set. Then we expect if we do the Lagrange form or if we use the Lagrange form, we should be able to get y equals x squared. Right? So, though nandun na yung solution, I usually find it easier to illustrate it by hand. So, sundan natin step by step yung solution. Remember that this is a data set of n plus 1 points. So, ibig sabihin ng n plus 1 natin ay 3. So, ibig sabihin n is 2. So, we expect a polynomial of degree 2 or less. So, I'm looking for a p2 of x. And the formula is that it is a sum of the function values or the y values given in the data set times the Lagrange interpolating polynomial, the Lagrange basis polynomial. Take the sum as I goes from 1 until n plus 1. And then if we want to create the interpolating polynomial now, so first term, I equals 1. So we need f of x sub 1. Unang function value is 1, so that goes there. Times yung Lagrange interpolating polynomial, Lagrange basis polynomial. So let's consider L1. Si L1, ibig sabihin meron akong 3 data points, so 2 factors meron kay L1. Tapos, dahil ito yung first Lagrange basis polynomial, ibig sabihin x1 yung minuend sa baba. And then I will put all of the abscissas possible here to be the minuend. Of course, again, I cannot put an x1 here kasi magkakaroon ng 0 sa denominator. So we are forced to start with x2 and then end up with x3 over here. So that's the first term in our interpolating polynomial. And then we repeat the process. This time, let's do I equals 2. So second function value is 4. That comes down here. That's f of x2. Times, we have the Lagrange basis polynomial, which is of degree 2. Tapos second to, so x2 minus, and then I should have an x1 here and x1 here. I cannot put an x2 as a subtrahend because that will cause a 0 in the denominator. So I'll go to x3. I'll proceed with x3. And then let's finish it off by using the third data point. Function value 9, that goes down here as a multiplier to the third Lagrange basis polynomial. X minus blank times x minus blank. And then this is the third Lagrange basis polynomial. So I'll have an x3 here, and I'm going to use all the abscissas possible. So x1 is fine as a subtrahend, x2 is fine as a subtrahend, x3 is not fine as a subtrahend because I'll have an x3 minus x3, okay? And if you observe, so we're done. We have used all 3 points. We expect 3 terms in our sum. And then each of the terms is of degree 2, right? Kasi meron ka lang x squared once you multiply everything. So indeed, this is the Lagrange interpolating polynomial. Okay. So is that clear? Nagbe-make sense na ba yung pagbuo ng Lagrange interpolating polynomial? Okay, thank you. Now, kung pag-iisipan nyo, parang napaka-clever ng pagkaka-create ng Lagrange interpolating polynomial. Actually, kung titingnan natin, okay, ano yung mangyayari pag pinlogging ko si x equals 1? Okay, pag pinlogging ko si x equals 1, magzi-zero itong factor na to. Alright? Kasi magkakaroon ka ng x1, pag nag-plugging ka ng x equals x1, the numerator becomes x1 minus x1. So this guy will be 0, making the entire second term equal to 0. Tapos ganun din yung mangyayari sa third term. This would be x1, this guy goes to 0, the entire term goes to 0. So when x is equal to 1, all that matters is the first term. Alright? Pero ano yung mangyayari pag pinlogging ko si x equals x1? Lahat ng x's magiging x1. So the first factor becomes 1. The second factor becomes 1. So I'll have a 1 times 1 times 1. So that's going to be 1, the first function value. Ganun din, if x is equal to 2. If x is equal to 2, this guy and this guy will both be equal to 0. So therefore, the first and the third term are just both equal to 0. So all that matters when x is equal to 2 is the second term. And what happens when you use 2 in the second term? If you use 2 in the second term, ito ay magiging x2, ito ay magiging x2. So this guy goes to 1, this guy goes to 1. 4 times 1 times 1, we get the second function value. Ito yung tinry kong ipaliwanag dun sa proof kanina, nung isang araw. Yung value ng Lagrange interpolating polynomial ay either nung Lagrange basis polynomial is either 1 or 0 sa mga abscissas. Nagiging 1 siya kapag match yung abscissa number at saka yung Lagrange basis polynomial number. Tapos nagzi-0 siya kapag hindi sila equal. Actually, dapat pala ginamit ko na yung actual x2 at x3 dito, no? Hold on. x2 should be, dapat sinulat ko na yung saktong mga x's. But anyway, we have that here, and the final answer here. Pinalitan ko na yung x2, yung x3, tapos ito na yung x1. Nakalimutan ko siyang gawin dun sa handwritten solution. But anyway, simply plug in the exabytes, x1, x2, and x3 in that formula that we got. And if you're patient enough, you will see that this long algebraic expression here will simplify to x squared as we have expected. Okay. Kung mahilig kayong mag-compute by hand, so this is a perfect exercise for you. Okay, let's look at example 2. Example 2 naman, same problem. Find the interpolating polynomial. However, I added a fourth data point, 4, 16. But notice that 4, 16 is also one of the points in the parabola y equals x squared. So ang candidate ko pa rin dito ay y equals x squared kasi yung y equals x squared dadaan dun sa lahat ng 4 na data points. Okay? And then we have 4 points. So the algebraic interpolating polynomial will be of degree 3 or less. Kasi yung AIP, algebraic interpolating polynomial, ay laging 1 degree, yung degree niya ay always 1 less than the number of points. Sorry, yung maximum degree niya ay laging 1 less than the number of points. So here, since we have 4 points, so we're expecting a polynomial of degree 3 or less. But we already knew that y equals x squared passes through all of the 4 points. It is of degree 3 or less. In fact, it is of degree 3. So posibleng or dapat si y equals x squared pa rin yung makuha nating AIP pag ginamit natin yung Lagrange form. Kasi nga, by the Unisolvance Theorem, unique yung makukuha nating algebraic interpolating polynomial. And true enough, if you will do the same thing as what we did, for example, 1, medyo mas mahaba yung polynomial na makukuha nyo. Kasi bawat isang term would be cubic. Kasi magkakaroon ka na ng x minus x2, x minus x3, x minus x4 para na numerators dun sa first Lagrange basis polynomial. Tapos meron ka ng 4 na terms ngayon. Right? But when you simplify this long expression here, you will find x squared, which is as expected. Okay? Kasi nga, unique yung Lagrange interpolating polynomial. So what I'm trying to illustrate in example 2 is that really deficits in the degree and the number of data points -1 can occur, especially if there's a redundant information in your data set. So from the point of view of the Lagrange interpolating polynomial, or the algebraic interpolating polynomial in general, the fourth point doesn't add any new information that we already knew from the first 3 data points. Okay. Tapos, kaya naging posible na mas maliit kesa kay 3 yung nakuha nating degree ng interpolating polynomial. Okay? Now, jumping to example 3, kamukha ng examples 1 and 2, kaya lang ang kinonsider ko lang ay yung unang 2 points, 1, 1, and 2, 4. Although, si y equals x squared pa rin could be a candidate, x squared nga, could be a candidate for the AIP kasi y equals x squared will pass through 1, 1, and 2, 4. But the problem is the algebraic interpolating polynomial has a maximum degree equal to the number of points -1. We have 2 points, so the maximum degree of the AIP is 1, right? So ang AIP natin should be of degree 1 or less. And definitely that is not satisfied by y equals x squared. So we will get an AIP different from x squared because the x squared mas malaki yung degree than what we are expecting. Okay? Now, true enough, if you will do that, okay, i-form natin yung interpolating polynomial para kay 1, 1 and 2, 4. So we'll have P1 kasi ang n plus 1 ay 2, so ang n ay 1. First function value is 1 times, magkakaroon lang ako ng x minus 2 over 1 minus 2 plus second function value times the Lagrange basis polynomial, which is x minus x1 all over x2 minus x1. Okay? And then if you simplify this, I think you get 3x minus 2. So when, let's check if it is really the AIP. When x is equal to 1, this guy becomes 1, so function value I1, that's a check. And then when x is 2, this would be 3 times 2, so that's 6 minus 2, so we get the 4. And then its degree is 1, which is 1 less than the number of points, so definitely 3x minus 2 is the AIP for this data point, or for this data set. Okay, so any questions? Kaya nyo na bang bumuo ng AIP? Ganito yung nasa exercise. Okay, good. So that's good to know. Kaya lang, syempre, pagka marami ka ng data points, hindi na kayang or hindi na masayang gawin siya by hand. Because say, if you have 100 data points, then that means your interpolating polynomial will be of degree 99 at the worst case. Tapos, bawat isa, merong magkakaroon ka ng 100 terms dun sa summation. Tapos, bawat isa sa kanila ay degree 99. So, medyo hindi na siya masayang gawin. So, that's why we usually use programming softwares or computing softwares in order to find the AIP. And probably for the rest of the meeting, I'm going to show you how to do it in Matlab. Although sabi nga natin in Math 174, you are not required to use any specific programming language. You can use anything of your choosing. So bahala na kayo. Pero what I want to use ay Matlab pag nag-illustrate ako sa klase. But because anyway, if you understand the process, putting it into the language of your computing software is just a matter of syntax. So pag alam niyo na yung pseudocode or naintindihan niyo na yung algorithm, maliit na bagay na lang na ita-translate niyo siya into the appropriate language or the appropriate syntax. So let me share my computer screen so that I can show you Matlab. So again, I love Matlab because madali siyang gamitin. Tapos sanay na ako siyang gamitin. Siya yung ginagamit ko sa research ko. And it also comes with the university has a subscription to it. So libre nyo siyang ma-access using your at up.edu.ph accounts. Tapos napaka-powerful niya. Hindi siya mahirap gamitin because it's a high-level programming language, meaning napaka-minimal nung programming skills na kailangan. It is built up on C++ or C++. I'm not sure which one of those two, pero hindi niyo na kailangan matutong mag-program ng C++ or C++. It is almost like a calculator kung paano siya gagamitin. Plus, it has a lot of intrinsic functions. And marami siyang apps na pwedeng gamitin or packages na pwedeng gamitin. Like optimization, curve fitting. Actually, it also has PDE solver, ODE solver. Ano pa bang meron ako dito? It has signal processing, which I do for my research, image processing, and so on. So computational finance, it also has some packages, and UP has access, or our UP subscription has access to all of these packages. At hindi mura ang license ng Matlab. Parang ang basic ng Matlab ay $500 yung lifetime academic license, pero wala pa siyang packages. So each package, I think, is also $500 for teachers and students. So yeah, so that's why I want to take advantage of it. So gamitin natin yung Matlab. Okay. So all right, let's start. So I want to go back to the epidemic problem we started with last time. So you can see it in the introduction of module 2. Okay. So dun sa epidemic problem, meron lang tayong data for 1, 2, 3, 4, 5. Data for 5 days. So in that table, given in the module table 2.1, nakalagay yung number of days after the epidemic broke. And the number of days are 0, 10, 25, 50, and 100. Okay. Tapos given yung number of deaths on that particular day. So on day 0, of course, no deaths yet. Day 10, there are 8 deaths. Day 25, there are 4,251, and so on. So ito yung data. So si Matlab, or Matlab stands for Matrix Laboratory. So ang default data structure ni Matlab ay matrices. So if you have a set of data, it's easy to tell Matlab to treat it as an array or a vector. So kaya yung data set ko for the time values, nilagay ko into a 1-by-1 vector. So ang mga vectors kay Matlab ay secured by square brackets. Tapos kapag ka spaces or comma, yung ginamit yung separator between two numbers, ibig sabihin ay magkaka-row sila. Nag-adjust lang ako ng column. So the way I wrote the vector t here, this vector is 1/5. 1 row, 5 columns. Kasi sineparate ko lang sila by spaces. But if I put semicolons after the numbers, okay, so 0, semicolon 10, semicolon 25, semicolon 50, semicolon 100, this is now a 5-by-1 matrix or a 5-by-1 vector. Kasi kapag ka naglagay ka ng colon, ibig sabihin next row na yon. So, pero I'll stick with a row vector para dun sa dataset. Tapos kung may constants ka, iniisip pa rin ni Matlab ay matrix siya, pero 1 by 1 matrix yung iniisip niya. Okay? So, which is still fine for us. No big problem there. Okay? So, the first lines 3 and 4 are basically data initiation. Finite ko lang kay Matlab ano yung information I know from the problem. Now, if you notice, I have a line here, line number 1, sims t. The syntax sims, syms, this just tells Matlab that everything that follows this command should be treated as symbolic variables. So, ibig sabihin dito, dineclare ko si t para maging symbolic variable. So, kaya pwede ko siyang gamitin as if it is an algebraic expression. So, kasi iisipin ni Matlab yung variable t posibleng isa siyang data handle or isa siyang handle para sa numbers or isang vector or matrix. By declaring that t will stand for a symbolic variable, alam ni Matlab na wag pakialaman si t. Kasi siya yung variable dun sa polynomial o mga functions na i-declare ko later. All right. Now, let's go to the meat of the program. Litan ko lang yung command window. I think medyo may delay. May delay nga ba sa pagka nag-explain ako ng code? I don't know what's happening. Pero I apologize for the inconvenience kung medyo delayed yung screen share and the broadcast. So, yeah. So, I hope you now see lines 8 to 17. Ito yung bulk ng pagde-define ng Lagrange interpolating polynomial. Remember, the Lagrange interpolating polynomial is a summation. So, it's a summation over k. So, sum siya ng f of xk times the Lagrange basis polynomial sub k. Kaya meron ako ditong for loop para kay k. And since I am expecting that I will do a summation to define the Lagrange interpolating polynomial, kailangan ko ng initial value para dun sa polynomial. So, if you'll see in line 16, p yung tawag ko dun sa interpolating polynomial. Okay? Dahil siya yung interpolating polynomial, tapos it is formed by doing a summation, dapat mag-initialize ako ng value sa kanya. So that's why I have in line 6 an initialization of p to the value 0. Okay? And now, pwede ko nang gawin yung summation. Ibig sabihin, si p ay magiging previous value ni p plus d of k. Yung d of k, siya lang yung pang k na entry nung vector d. If you remember, the vector d is the number of depths in our data set. So yung d of k, siya yung pang k na entry ni d. Because that's the function value times lk. lk is my symbol or my handle for the Lagrange basis polynomial of order k. And how do I find lk? Now, I find lk by, remember, it's a product of certain fractions, x minus xi over xk minus xi, when I is not equal to k. And that means I need a for loop for that. Okay? So, para dun sa pag-form ng Lagrange basis polynomial, yung lines 11 hanggang 15. So now the iteration goes from 1 to, hindi ko pala na-explain tong size. Yung size, kino-compute niya yung dimension ng vector na nasa loob niya. So for instance, if you write size of t, siguro i-type ko sa command window. Kaya lang di ko pa siya na-initiate. If you ask Matlab to find the size of t, ibibigay niya yung dimension ni t. Remember, t is a 1 by 5 matrix. So, ang sagot sa size of t ay 1, 5 kasi 1 by 5 siya. Pero since I only want the second dimension, gusto ko yung 5 kasi yun yung number of data points in my set. So, kaya kinuha ko dito ay size of t, pero I ask Matlab to just give me the second dimension. Kaya when you try to compute size of t comma 2, bibigay niya yung second dimension ni t, which is 5, kasi yun yung number of columns. Okay? So the iteration goes from 1 to 5 as what we want. Pero dun sa, remember sa pagkuha ng Lagrange basis in polynomial, nag-multiply tayo ng paulit-ulit. It's a product from 1 to n plus 1. Okay? So kaya yung bagong LK ay product ng lumang LK. Go back there. Lumang LK. Oops. Times yung current expression. Ano ba yung current expression? It's according to sa formula, x minus xi, right? Pero ngayon, ang variable kong ginamit ay t for time, and then ti is the ith entry in the vector t. Okay? So ito yung parang x minus xi dun sa formula natin sa module over xk minus xi. Note the use of the variable t here. Usually, magrereklamo si Matlab pag nakita niya yan. Pag may t dyan pero wala kang inassign na value kay little t, magrereklamo siya na I cannot run the program kasi undefined yung variable t. But luckily, in line number 1, remember, we told Matlab, don't worry about t. T is a symbolic variable. So, yeah, kaya hindi siya magrereklamo dito sa for loop na yan. Okay? So this for, but of course, there's an exemption here. We don't want I is to be equal to k, because if that will happen, then this denominator will be ti minus ti. So magiging 0 siya, magrereklamo si Matlab. You are asking me to divide by 0. Or actually, Matlab will just treat that as infinity. Okay? Pero ideally, we don't want that to happen. So kaya meron ako ditong if construct, which will filter out the factor that will be formed if I is equal to k. So dito sa step na to, lines 11 to 15, mako-compute ko yung Lagrange basis polynomial. And then all that we need to do to find the appropriate term in the algebraic interpolating polynomial, function value times the corresponding Lagrange basis polynomial, and then we'll take the sum of all of them, then we'll get the polynomial p. Let me just comment everything else here. I want to show you how it is run. Okay. Yung pala, kapag ka kay Matlab, kapag ka merong percent symbol sa unahan, it turns whatever follows into a comment. So ibig sabihin, Matlab will ignore what is after the percent symbol. So hindi niya iraran yung mga yon. So to run this Matlab program, you can hit F5 or merong play button dito sa taas, dun sa taskbar niya sa taas. So you can click on that play button. And you will note that your program ran kapag ka lumabas na yung file name dito sa command window. So yung command window dun sa ilalim, this is basically your display window. Dito lalabas yung mga pina-output mo kay Matlab. Now, sir, bakit walang lumabas? The thing is that I did not ask Matlab to display anything. Because kapag ka meron kang semicolon at the end of each line, Matlab will suppress the display. So hindi niya ilalabas yung mga values na yon. Kasi kung hindi ko naman siya kailangan kung hindi ko kailangan yung values nila for my purpose, hindi ko naman sila kailangan makita. So lalo na yung mga results ng intermediate computations. So that's why I put semicolons in there. So if you want to see the certain values of the variable, you can just type the variable name. So, halimbawa, si t. Gusto ko malaman ano nga ba yung ginamit ko na t na vector. So, you can type t. Oh, by the way, Matlab is case sensitive. So, capital T yung pangalan ko dun sa vector. Type t on the command window, press enter, then you'll get the vector t. And it is a row vector as expected, 0, 10, 25, 50, 100. But actually, I'm not interested with that. I'm interested with the algebraic interpolating polynomial. And remember, we called it P in our computations. The program ran, so it already has P on its memory. So type capital P on the command window, hit enter, and you'll see the Lagrange interpolating polynomial. Okay. Kita na ba sa screen niyo or wala pa? Minomonitor ko din siya dun sa tablet ko pero mukhang wala pa. Wait a little bit. There we go. So,
Kita na po.
dapat nakikita niyo yan. Okay, great. Thank you. So, hindi siya magandang tingnan, pero at least sa compute niya na yung interpolating polynomial. Okay. One way to have a prettier display is to ask Matlab or use the pretty function in Matlab. So, dapat daw mas maganda. So, pretty of P. Medyo minsan intuitive and sometimes witty yung pagkakapangalan ng mga functions kay Matlab. So, if you type pretty and put inside pretty a symbolic function or a symbolic expression, then it will try its best to present it in a nicer form, like this one. So pretty P, lakayan ko lang yung command window. Okay. Nag-effort si Matlab na isulat siya as a fraction. Hindi pa yata nakikita. Okay. In this way. So T times quantity T over 15 minus 2/3 times T over 25 minus 2 all over 25 minus and so on. Pero hindi pa rin siya maganda para sa atin, tama? Kasi mahirap pa rin siyang gamitin. So another way is to ask Matlab to simplify it for us. So you can type simplify kahit sa command window, or etong lahat ng sinusulat ko sa command window, pwede nyong i-type dun sa actual editor para i-display na ni Matlab. Hindi ko na siya ginawa sa editor kasi na-run ko na naman yung program. Nasa akin na lahat ng variables na kailangan ko. So pwede ko silang paglaruan na lamang dito sa command window na parang calculator. And then you will know what are the variables that are already in memory by looking at the workspace. So if you look at the right panel, you see a workspace here. Meron dyang D, I, K, L, K, P, T, and T. Ibig sabihin, ito yung mga variables or mga handles na available na kay Matlab to use at this current session. So hindi mo na kailangang i-run yung code kung wala naman na bago dun sa data, pwedeng sa command window ka na lang maglaro, like what I am doing right now. So again, I want Matlab to simplify the polynomial P. So the command is simplify of P. Okay. Tapos hindi lang yun yung gusto ko. Gusto ko ay pretty rin yung display. So pwede kong lagyan ng pretty sa labas, tas nasa loob yung simplify P. Okay? And if you hit enter, ito yung makikita ko. Okay. So you see here that Matlab simplified it nicely. So you have T times negative 150,469 T cubed. So just be careful, exponent ito. Yung nasa taas, so meron kang T cubed. Then here you have this big number times T squared. And then, ang kagandahan kay Matlab, if it is a symbolic variable, it will compute all the constants exactly. So makita nyo, hindi siya nag-decimal, hindi siya nag-round off, and so on. So kaya naka-fraction form pa rin siya. Okay. Now, if you want to see a symbolic variable in decimal form para i-simplify nyo yung fractions, I think you can use VPA. Tapos supposedly, kokopyahin ko tong output na to or yung input na to. Kaya lang kasi hindi ko siya na-store sa isang variable. So kung gusto kong gamitin yung result ng previous calculation, pero hindi ko siya na-save or na-assign sa isang variable, pwedeng ANS yung gamitin ko. So yung ANS, siya yung default variable para sa previous result. Let me see if that will work kasi wala akong ANS sa workspace. So let's see. Hindi siya lalabas kasi hindi pala ito nakadefine para maging si ANS. Pero what you can do is to copy this command, paste mo lang. Try ko nga kung papasok siya sa VPA. Hindi ko sure kung mag-work siya sa VPA. Yeah, hindi nga siya mag-work sa VPA kasi naka-pretty pa siya. Pero I think VPA of simplified. Let me see if this will work. Yeah, there you go. So sa VPA of P, makikita mo in decimal form yung interpolating polynomial. Though hindi rin siya ganon, kagandahan pa. Okay. So, okay. Let me see. Going back to the code, Sorry, it's already 10 minutes before time. So if you guys have classes after or you have to go, yeah, you can do so. Feel free. Pero if you don't have anything to do for the next 5 or 10 minutes, you can stay. Tatapusin ko lang yung pag-i-introduce kay Matlab nito. And then if you have to leave, you can just watch the recording later. And then since I will not be able to finish module number 2 today, I'll ask our lab instructors to continue the discussion on Monday. Tapos dahil magdi-discuss pa kayo sa first hour on Monday, you might not have enough time to finish the laboratory exercise. So we'll move the deadline of Lab Exer 1.1 to Wednesday. Okay, Wednesday at 11:59 p.m. So I think the lab exer is designed for 1.5 hours, and then meron kayong discussion for the first hour. So that will just eat up 2.5 hours of your Monday, which is still fine because your lab classes are 3 hours in length. Pero to give you more time, probably kasi baka discussion lang or may questions kayo about the lab exer, you can spend the entire laboratory class for your questions, clarifications, and so on. Do your attempts, but I'll give you a couple more days to finalize your answer. So again, Lab Exer 1.1 will be due on Wednesday, okay? Right before midnight. Okay? So I hope that's fine. That's fair for you, okay? So gusto ko lang ituloy para ma-introduce na kayo kay Matlab para pwede nyo na rin tong gamitin later. Actually, pwede nyo ang gawin, screenshot nyo tong code na to, palitan nyo lamang yung data, magagawa nyo na yung Lab Exer 1. Posibleng palitan nyo lang yung variable instead ng t, gawin yung x. I don't remember what's the instruction in Lab Exer 1.1, but basically you can use this code para dun sa exer. Okay? So let me see what I want to do here. Okay. So let me just uncomment this portion of the code. Nakita na natin ano yung ginagawa nila. Okay. So, but look at line 20. I have simplified P kasi di ba hindi pa simplified yung ibibigay na P coming from the for loop. Okay. So I will ask Matlab to simplify P and then overwrite the handle P by the simplified version of P. So assignment command kay Matlab by equal sign. So this means P is now assigned to the simplified version of the previous value of P. And then pretty P here, walang semicolon yung pretty P. Itong pangalawang pretty P, walang semicolon. So ibig sabihin, i-output ni Matlab yung prettier version ni P. Okay? Now, line 22, what is line 22? Kasi symbolic yung variable. So what if we want to get the value of the polynomial or the function P at certain t values? For that, we are to use the substitution command, which is subs, S-U-B-S. First argument ni subs ay yung function na gusto nyong i-evaluate. Second is, saang variable mo gustong mag-substitute. So since P only has one variable, and that's t, so t lang naman yung option ko dito. Tapos, ano yung third argument is, ano yung gusto kong i-plug in dun sa mga t's kay P. And here, I want to plug in the values inside the vector t. So hindi ko na siya kailang ilagay sa for loop para gawin niya sa bawat element ni t. Pwede ko siyang ibigay na lang si vector t because again, Matlab by default works with matrices and arrays. So ibig sabihin, okay lang na array yan. I-evaluate niya si p sa bawat entry ni t. Okay? So if I again hit F5, this code in the editor will run. You will see several outputs here kasi merong mga hindi naka-colon. So ito yung pretty version ni P. Ito yung simplified version ni T. And this is the substituted values. Function values ni P evaluated at the given abscissas. And you see these are exact if you compare it to our table, confirming the fact that this is our algebraic interpolating polynomial. Okay? Now, usually, we want to interpret the results of our calculations. So usually, looking at figures will help rather than just looking at the polynomial itself. So if you look at lines 24 and 25, nandito yung plotting command. So the figure command, sinasabi lang nito kay Matlab na mag-create ng isang window para dun sa figure na i-create ko. So preparation lang siya. And then right after the figure command, yung fplot, ito yung command para mag-plot ng symbolic function. Now, first argument is the function to be plotted. So gusto kong i-plot si P. Second argument is a vector, whose first component is the minimum value over which we will plot the graph of P. And the second entry is the maximum value for the variable. Okay? So ibig sabihin, yung plot kong makikita will have T values starting from 0 until 100. So either you run the entire program again, or copy-paste it in the command window. That's also fine. But another way to run certain parts of the code para hindi nyo kailangang i-rerun yung buong code dahil nasa workspace na naman yung variable P, pwede ko na lang itong i-right-click and hit evaluate selection. So yung evaluate selection, lahat lang na naka-highlight ang i-run niya para hindi nyo kailangang i-run yung buong part ng code. Or you can just highlight the portion of the code you want and press F9. So parehas lang yun yung evaluate selection. So if I evaluate the selection, nag-run si Matlab, mabilis to dapat, hindi ko alam nag-acting yung computer ko ngayon. Pero anyway, yeah, there you go. Here's the figure for the epidemic plot, okay? From time equals 0 to 100. So ito yung degree 4 polynomial that you obtain when we use the data points. And if you look at the graph, you see, oh, the epidemic hit its peak around between 70 and 80 days. Kasi nandun yung maximum casualties dun sa epidemic. Okay? And you see that it will eventually subside as we near T equals 100. Na-flatten na yung curve or naka-vaccine na or nagkaroon na ng herd immunity dun sa tail end nung time frame. Okay? Pero halimbawa, we want to be more specific about it. Kailan naganap yung maximum number of casualties? Well, we can now apply tools we learned from Math 36. Remember, sa Math 36 ay kaya nating maximize ng isang function, right? So to maximize a certain function, we need to find the derivative, equate it to 0. We'll get the critical numbers. And the critical numbers are the candidates para dun sa maximum or minimum value or maximizer or minimizer ng given function. But here, we don't need to compute them by hand. Matlab can also differentiate a given function. And the command is diff. So if I will type it in the command window, diff, tapos ilalagay ko lang sa loob ni diff yung function na gusto kong i-differentiate. If I hit enter, I'll get this long expression, which is basically the derivative. Or I can ask Matlab to display in a pretty fashion yung derivative ni P. Okay. So ito yung derivative ni P na naka-pretty format. Okay. Now, maybe I want to plot the derivative. Para lang ma-double check, nagme-make sense ba yung result ni Matlab? So look at lines 27 and 28. Here I am asking Matlab to plot the derivative. Okay, I'll evaluate selection, and I'll get this figure. So this is the plot of the derivative of the interpolating polynomial. Wala naging problema si Matlab kasi polynomial yung model natin. Pag dinifferentiate mo siya, polynomial pa rin. And indeed, we see that, remember, ang critical numbers natin, kailan nag-zero yung derivative. So there is 0 is here. So merong critical number between 0 and 10. And then there's another critical number here between 70 and 80 as we expected kasi alam natin yung graph ni P. Now, if we want to see the actual critical numbers or the actual minimizer or maximizer of our function, kailangan nating computein kailan talaga nagzero yung derivative. Luckily, Matlab has a intrinsic function, how to find the roots of polynomial. So, kung hindi nyo alam yung code, bago kayo kay Matlab, madali namang gamitin yung documentation or yung help niya. So, if you go to the upper right of the screen, meron dyang field, yung search field. Type nyo lang halimbawa roots. Kasi gusto ko mahanap yung roots ng polynomial, which is the derivative of p. Kasi nandito yung several options. So, mukhang ito yung kailangan ko, yung una, polynomial roots. So, click polynomial roots. It will direct you to the documentation page. Okay. Tapos, meron dyan description. Bibigay niyo yung syntax. So, yung syntax r equals roots p. So, kung computein niyo yung roots, i-assign niya sa handle r. Pero ano dapat yung input p? Nasa description naman siya. It says here that input p is a vector containing n+1 polynomial coefficients. Tapos may example pa siya. Kung gusto mong kunin yung roots ni 3x squared plus 2x minus 2, kailangan mo yung vector p to contain the coefficients. Tapos ang maganda kay Matlab, meron pa siyang help. So nandito kung ano yung kailangan mong i-type para makuha yung wanted result. Okay? Kaya lang sa atin, baka medyo mahirap yon kasi malaki yung degree ng polynomial natin. Meron na tayong polynomial p, na-compute na natin yung derivative niya. So ang problema ay pag-harvest ng mga coefficients. Luckily, we can also ask Matlab to do that for us. So ang command para ma-harvest ang coefficients ng isang polynomial ay sim to poly. Bakit sim to poly? Parang i-convert niyo yung symbolic variable to a polynomial vector of coefficients. Kaya yun yung tawag sa command niya, sim to poly. Tapos lagay lang natin yung ano yung gusto nating hanapin. What's the symbolic object that we want to put inside sim to poly? For us, that is the derivative of p. Okay? Tapos i-set ko to or i-store ko yung value sa variable na coef. So coef now will be computed to become the vector consisting of the coefficients of the derivative of p. Hit enter, and I'll get these values for coef. Okay? Tapos, since si coef, siya na yung coefficients ng polynomial, pwede ko na itong ilagay dun sa roots. So, halimbawa, yung roots nung derivative, alam ko sila yung critical numbers, kaya i-assign ko siya sa handle na cn for critical numbers. Tapos ko-computing ko yung roots. Pero remember, sabi nung help, ang inputs dapat ni root ay vector consisting of the coefficients. But I already computed the coefficients and put it into the handle coef. So hit enter. Ito yung roots. And true enough, 73.7115, negative 28.0290, and 5.0918. Actually, na-imagine na natin itong yung first at saka yung pangatlong critical number. Right? And observing the graph of the epidemic curve earlier, we knew that there is a maximum between 70 and 80. So probably that would be at 73.7115. If you want to know what's the maximum number of death according to our data, well, you can just substitute 73.7115 for all the t's in the polynomial p to get the number of casualties at that particular day. So I'll do p, para ma-compute ko yung maximum number of casualties. Remember, ang command ay subs. Unang entry ay yung polynomial kung saan ka mag-substitute. Aning variable na papalitan natin by the constant. So t lang naman yung variable. Tapos, ano yung ipapalit ko dun sa variable t? I want 73.7115, so pwede ko siyang ilagay dito. Pero yung 73.7115 truncated yung display to 4 decimal digits, but Matlab stored more than 4 decimal digits. So what you can do instead is if you want to plug in the exact number or gusto nyo gamitin yung maximum precision ni Matlab, pwede nga gawin nyo ay dahil naka-assign naman kay cn etong vector na to. So pwedeng tawagin ko si cn tapos kunin ko yung first entry niya. Kasi yung 73.7115 siya yung first entry, right?
So, kunin ko lang yung Cn of 1. Tapos, closing parenthesis for subs, hit enter, I'll get this exact value. So, pag exact value yung hinanap ko, covered pa rin kayo kasi this big a number, diretso pa yan, over, nasan yung over, yung fraction bar? Over this guy. So, super exacto yung pagkakakompute ni Matlab. Pero if you want to see a decimal representation for it, you can type double. Tapos, oh, unfortunately, hindi ko na-save to a variable or to a handle yung value na to. Okay? Pero luckily, pagka nagko-compute ka ng numbers or symbolic variables, usually by default, ini-store siya ni Matlab sa variable na ans for the answer. The previous answer is always stored in ans. So kahit hindi ko siya na-save, merong backup si Matlab na, oh, tinawag kong ans, yung previous answer mo. So pwede kong ilagay yung ans sa loob ni double, and I get a scientific expression with double precision para dun sa previous answer, which is 3.2131 times 10 to the 4th power, or around 32,131. An alternative to double is VPA, para makita nyo yung decimal places. Pwede kong gamitin yung ans kasi ang previous answer naman natin ay ito, which is equal to the number of maximum number of casualties pa rin. So VPA of ans, hit enter. So there we go, a decimal representation, 32,131. Which is, if you look at the graph again of the epidemic curve, okay? Yeah, yung peak ay nandito, alam na natin this is around 73.7115 days. Tapos ang maximum ay 10 to the 3 times 10 to the 4th plus some change. So okay tayo doon. Tapos remember, may isa pang root yung derivative, tama? Nasa 5 point something. And that is actually the minimum here. Okay? Kasi, yeah, parang nag-negative pa nga dito yung number of deaths sa 5 point something. But that would be the minimum. Okay? Now, I guess the last thing I want to say, dahil nandito pa rin naman kayo, sorry, over time. Pero luckily, ang next period yata ay 10 pa naman, no? So, pero yeah, since you're here, dun sa module, tinanong, what if a researcher wants to look at a weekly breakdown of the data or weekly number of casualties due to the epidemic? So, gustong i-evaluate ni researcher, makita what are the casualties at day 0, day 7, day 14, day 21, and so on. Obviously, we cannot give it to him or her because our data only has 5 points. Tapos sila ay 10, 25, 50, and 100. Gusto ko weekly or gusto ng researcher weekly. So, but luckily, we have a model, a polynomial model for the epidemic from day 0 to day 100. So, pwede ko na lang i-plug in yung kahit anong gusto kong t-value yung sa polynomial, and it will give me an estimate of how many deaths occurred at that particular day. So, dahil gusto ko yung weekly data, gumawa na lang ako ng vector. I'll call it TW para weekly time values. Starting from 0 with increment 7 until 100. So, ito yung syntax para bumuo ng isang vector with a constant increment. Starting from first value, colon, ano yung increment, colon, hanggang kailan. So, ang gagawin ni Matlab, mag-create siya ng vector. Ang first entry is 0, second entry is 7, third entry is 14, 21, 28, and so on, hanggang makaabot siya ng 98. Pero after ng 98, 105 na, lampas na sa 100, so hindi niya na i-count yung 105. So, if you hit enter, you'll see here you'll get a vector starting from 0 as we expected, 7, 14, 21, 28, hanggang 98. Okay? And then, if I want to see the data, ang gagawin ko na lang is a substitute ko kay P, papalitan ko lahat ng T by the values of the vector TW para makuha ko yung weekly estimate for the casualties in the due to the epidemic. Hit enter. You'll see this. This is the casualties day 0, casualty day 5, which doesn't make sense kasi negative value. Pero let's just ignore that. That's the cost of modeling. Kasi napaka-crude ng model natin. Wala tayong check kung kailan siya feasible yung value, and so on. Fractional sila. So if you want to get decimal representation, so just type VPA and ANS. Kasi ang ANS so far ay equal dun sa substituted values. Okay. Hit enter, you'll get this. 0, negative 209, 617, 2598, and so on. Okay. Kung medyo mahirap mag-browse dito sa command window, one way to see the results of your data would be to go to the workspace. Medyo maliit nga lang sa screen ko yung workspace. Pero dun sa workspace, pwede nyong i-click yung variable name or yung handle name. Halimbawa, si ANS, siya yung result na kaya lang pala si ANS ay symbolic. So siguro, pag kinlik ko kasi si ANS, i-display niya ay symbolic variable. So what I can do is say, I will assign, how do I do it? The number of deaths equals double of ANS. Hopefully yung double, i-convert niyo yung symbolic variable into a double precision variable. Yung BPA kasi display lang siya. So dinisplay niya in decimal digits pero wala siyang ginawang conversion. Pero this time, the double command will translate the symbolic variable into a numeric variable with double precision. Luckily, ginawa niya yan. Ito pala, be wary about Matlab. Makita niyo, ito yung display hanggang 15. Tapos parang mali, 0.5738. Pero kanina, thousands yung nakita natin. You need to scroll up to the beginning of the result. Scroll up ako, merong multiplier dun sa labas ng column vector. So everything inside this vector is multiplied by 10,000. So this is 10 to the 4th. 1 times 10 to the 4th. Now dahil hassle na tingnan yung data this way, I can go to my workspace. Dahil itong substituted values, tinawag ko na DW. So I can click on DW dun sa workspace, double click, tapos makikita ko siya in an Excel-like format. So ito yung estimated number of deaths for on a weekly basis. Okay. Now let me see. I think that's all that I want to show to you today. Okay, let me end this. Any questions? Yeah, nagreklamo si Teams, bad network quality. But hopefully I sent across. Yeah, any questions? Sorry, medyo overtime, pero I want to share this with you para magamit nyo if ever sa recit nyo on o sa lab nyo on Monday and in doing your lab exer. Oh yes, Joshua.
Hello po sir. Ask ko lang po sana yung para sa lab exer po about sa mga questions. Lalo po dun sa interpolating. Complete, halimbawa po gumamit ng program, i-include po ba halimbawa yung screenshots ng code or kahit yung answer na lang po? Parang ganun.
Yeah, good question. Unfortunately, I cannot answer that kasi ang usapan namin yung lab instructors nyo ang mag-check ng lab exers. So, kindly ask them kung ano yung preferred nila. Actually, tatanungin ko din sila later kung i-require nila kaya na i-submit yung code. Okay? Kasi personally, kung ako yung mag-check, hindi ko na kailangan tingnan yung code nyo. Yung final answer lang yung gusto kong makita or kung ano yung talagang tinatanong nung problem kasi hindi naman to programming course. So, ayoko nang tingnan yung code nyo. Though may drawback siya, hindi ko kayo mabibigyan ng partial points. Pero ayun. Unfortunately, I cannot decide. I already gave your lab instructors the freedom to decide. So, sila na lang yung tanongin nyo. Mag-meet pa naman kayo on Monday para alam nyo kung ano yung preference sila. Kasi anyway, sila naman yung mag-check. So, yan. Yan pala yung hatian namin. Sila yung mag-check ng problem sets. Sila yung mag-check ng lab exers. Ako yung mag-check ng problem sets. So sa problem sets, hindi nyo na kailangang ilagay unless sabihin ko na display the polynomial. So magiging specific ako sa instruction sa problem set. Pero yun. Pero sa lab exercise, hands off ako dyan. Ayoko mag-check ng lab exercise. So yung lab instructors ang tanongin niya. Okay?
Okay po, sir. Thank you po.
All right. Any other questions? Okay, if there are none, then that's it for us today. I hope you enjoyed the rest of the day. Enjoy the weekend. You need it. Baka marami na kayong pinagdaanan this week. So enjoy the weekend. Find some time to rest. Be with your family. Be with your friends. And then para refresh kayo pagbalik natin on Monday. Okay? So again, Lab Exer 1.1 is extended until Wednesday right before midnight. If you need more time, just let me know. Pero feeling ko kaya na yan by Wednesday. Okay? So that's it. Bye, guys. Thank you for coming today.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Salamat.